Hello guys. My name is Akshay Kumar Dwivedi, and today I'm going to explain you my code, my project that I did in Prettyguard Education Center, which was online. So my project name was how to compromise water quality assessment. So in this I did is some data features which is initialize the nine factors of like pH, hardness, solid, and the ability to make predictions. And the main goal was the project is uh, we have to predict water is safe to drinkable or not using data science and Python. And the algorithm which I used is to compare two machine learning models, decision tree and k nearest neighbor, KNN. And the dataset was normal in an Excel sheet. It was given by the repeating guard itself. So, which was the Andhra Pradesh and a larger artificially created dataset. I uploaded this. I'll show you later. Key results was the KNN model, nearest neighbor model, was found to be more accurate at predicting water probability than the decision tree model. So here's my project. In this project, I also use some Python libraries like I import the pandas PD and NumPy. Panda for the reading and cleaning, the analyzing tabular water quality dataset in the which I was already given. And for num, I also imported the NumPy, which was for numerical operation and mathematical calculation, mean standards and standard statistics and then normalizations also. And I also import the matplotlib and dot pyplot, which was the for basic 2D plotting and data visualization, like in a charts form or in a bar graph chart form. And also a cburn. Cburn was the for advanced statistical and correlation plots, like the heat maps, blocks plots, and pair plots. And I will show you that later. And I also import the sklearn dot model selections, which was the for it's used to divide the dataset into training and testing set. Sklearn dot select is dividing the dataset into two parts: training and testing. Sklearn dot uh, inassemble. It was for the to build a predictive and model using decision tree. And sklearn.linear model, it is for binary or multi-class water quality classifications. And for the sklearn matrices, it contains the performance evaluation functions like the accuracy score, precision score, recall, F1 so and the classification report and conclusion reports. So what I did first, I load the dataset, which was the Excel sheet. Uh, by this, the tfpd.read Excel, and I copied the path of that file. I and I paste here. Then I run. Then the dataset was here. The output you can see. The dataset is there. And second, what I did is initialize. I initialize an instruction column cleaning, like the pH and hardness solid and chloramines, sulfate, conductivity, organic carbon, and the three influence and turbidity probability also. DF shape is for the showing the data. Here's the output, you can see that. And this is the other thing. The attempt to reconstruct proper column by searching for known header tokens. And I'll try to which I tried two approaches. Like the first row contains a combined header text and phrase it. Otherwise, assume that column line is roughly. Here is the second thing which I did. You can see the output. First, I initializing the values Also data, then I data and I cleaning the data by converting columns into appropriate number type numeric types, handle the missing values by the median imputation, detect and optionally remove outliers using IQI method. Here's the code. You can see that like the data dot apply p numeric errors, data print missing values for columns after median imputation missing counts, and here's the output. The column name is here, and the non-null counts data type, and their data type also the float call floats also. This is the statistics part, which are data descriptive statistics, computed mean uh, max for each parameters and on both original imputed and clean data set. That is, I use the statistics to clean the data. Here's the output. This was the full data set, and this is the clean data, which I after outliers removed. Here is the visualization part. Using histograms, box plots, correlation, and heat map, I visualize the data in charts and graphs. These are some keywords: plot figure, histogram for hist, titles, and labels also. And for the print of they were show. Here's the histogram of the pH value. Here, this side is the count, and this side is the pH. This is for the histogram of hardness. That is the histogram of solids. Here is a count and here is a solid. You can see that histogram of fluoramines. And this is histogram of sulfate. Here's the count value and the sulfate value. That is for conductivity, histogram of conductivity. That is for the organic carbon. So here you can see that I use the histogram for each and every column, from pH values to their hardness, durability, organic or organic carbon, turbidity, and potability also. Here is the box plot for the box plots. The box plot of pH, box plot of hardness. Here's the hardness, and here's the box plot, like one over. Box plot of solids, chloramines, sulfate, conductivity, organic carbon, 3-halomethanous, turbidity, and potability. This is the correlation heat map. You can see the pH value here. And I also check the WHO first, check against WHO safety and water limits. I also check the limit of there. The pH value limit is 6.5 to 8.5, and hardness is more with universal WHO limit, but often is more than the 50 mg, 500 mg. considered acceptable for printing, I think. Sulfate WHO guideline. These are the column names and there are the limits of there. None to 500, none to 1000, none to 4, like the minimum and the maximum values, maximum limit. Function to flag. Here the machine learning part. Create the portability. There I trained the random forest classifier and logistic regression as a baseline of that. If a probability is column is absent, we will create, and then I created a synthetic on one using TDS and uh, thresholds, but the real test dataset was normally as a portability label. I think might be something I did wrong in the project in the coding part, so that's why it shows the error. I will see that later and ask my professor also about this. What is so? That's the result. The result and conclusion was to summarize the findings. I summarized in the descriptive statistics, WHO flags, model performance, accuracy, precision, recall, happen. Discussion. I discussed the limitations of and the future work, like the collected label portability data and hyperparameter tuning, model explainability. Thank you everyone for watching this video. This was my project which I did